Welcome to our lesson on alpha decay. Okay, so again we have a do now. So I'd just like you to take a few minutes to answer those questions. Okay, so pause the video, and when you have answered the questions, start the video again and check your answers. Okay, so what is an alpha particle? We can say it's a helium nucleus. Okay. A beta particle is a fast moving electron. Okay, the mass of a beta particle is 0, okay, because it is a fast moving electron, has no mass. Mass of a gamma ray is also 0, okay. Charge on a gamma ray is 0, okay. If we were talking about an alpha particle, that would have a charge of +2, and a beta particle have a charge of -1. Okay, what can be used to block alpha? So we can have 10 centimeters of air, paper, or skin. Okay, what can be used to block beta? Okay, about 100 centimeters of air, so 1 meter, or thin aluminium foil. Okay, right, next slide. So today, as we said, we're talking about alpha decay. So what we're going to be doing is looking at what actually happens to an atom when it undergoes alpha decay. Okay, so alpha particle is identical to that of a helium nucleus. Okay, so we know it contains our 2 protons and 2 neutrons. When alpha decay takes place, it's emitted from the nucleus of an unstable atom. Okay, the unstable atom decays. When that takes place, the unstable atom then becomes a different type of atom. Okay, and that's because it's got a different number of protons. Because when it gives this out, it's obviously losing 2 protons and 2 neutrons. So its mass is going to change and its atomic number is going to change. All right. So if we look here, we can see we've got our unstable atom. It's just named X in this case. Okay, it's got a mass number and it's got an atomic number. So the mass number's at the top. And this is the atomic number. Okay, and when it gives out this alpha particle, okay, it's going to lose 4 things from the nucleus. Okay, so its mass drops by 4. Okay, its atomic number, because it's given out 2 protons, its atomic number drops by 2. Okay, so in your booklet you need to write down what happens to the mass number. So the mass number decreases by 4 when an alpha particle is emitted, and the atomic number decreases by 2 when the alpha particle is emitted. Okay, so pause that. You may need to go back, watch this bit again. Okay, we're just saying that the mass number decreases by 4, the atomic number decreases by 2. Okay, so pause that, get that written down in your booklet. Okay, so moving on. This is an example of alpha decay. Okay, so we can see atom on the left-hand side is unstable, hence it undergoes alpha decay, gives off an alpha particle, a helium nucleus. Okay, we've written He here, but it could be an alpha particle as well. All right, so what happens to it? Well, it gives off these bits. We've got to conserve our mass, so we've got to have the same mass of things. Okay, so over here we've got 226, a mass of 226. So if we take 222 and add 4 to it, we'd get 226. Okay, so the mass of these 2 things here, the products, is equal to unstable atom. Okay, also we can see that we start off with an atomic number of 88, and when our helium nucleus is given out, alpha particle is given out, the mass is going to drop by 2. 86 plus 2 is equal to 88. Okay, so we can just write 226 equals 222 plus 4. Okay, at the bottom we can write 88 equals 86 plus 2. Okay, so some really simple maths applied to something not so simple. Okay, alright, so this is our first problem. Okay, this is in your booklet. Okay, these are one of the problems you need to solve. So again, we've put a general rule here, okay, about A minus 4 plus 4. Okay, so the mass number drops by 4, but that's where that 4 has gone, okay? So this number plus 4 is equal to this number, okay? So let's have a look at our problem down the bottom. Okay, so let's look at our mass of 226, okay? And we've got a 4 there. So what we're working out is what number is going to go here to add 4 to it to give us that, okay? So we're going to do 226 equals something plus 4, okay? And we know that if we take away 4 from 226, we're going to get 2, 2, 2, okay? So exactly the same as the example we saw just now, all right? Now at the bottom, for the atomic number, okay, this time, this atomic number is going to drop by 2, okay? So something plus 2 equals 88, okay? Now we all know that 86 plus 2 equals 88, okay? So nice and straightforward. So we've got 222 plus 4 is equal to 226, okay? At the bottom we've got 86 plus 2 equals 88, okay? So simple maths, okay? Don't confuse yourself. It is just simple forward maths, okay? So another example, okay? So again, this time we have a similar mass. It's decaying, okay? And we need to remember what happens to this mass, okay? So what happens to this mass number? What's it going to drop by? Yeah, that's right, okay? It's going to drop by 4. So we're going to do 222 equals something plus 4, okay? And we all know that's going to be 218. So we put 218 in there, okay? And we can check that. 222 minus 4 equals 218. 222 minus 4 equals 218, okay? For the atomic number, we've got 86, and that's going to drop by 2. Yeah, so we're going to write down 86 equals something plus 2. Okay, so 86 take away 2, we're going to have 84. Alright, so our number is just going to be 84 in there. Okay, so what you need to do for the rest of this, and this should be really straightforward, is we're just going to work through these problems in your booklets. Okay, so we need to write in the mass number and the atomic number each example. Okay, if you're not sure what you need to write, okay, you need to go back and watch the video again. Alright, and then you can ask your teacher in the chat function underneath the assignment if you have any further problems. Okay, there are also 2 challenge questions on the booklet which are more difficult because it's not set out like this for you, but I have every faith that you'll be able to attempt them and should be able to get them right. Okay, right, thank you very much, good luck,